So for this project, we're going to be talking about a correlation between the decline in health in urban forestry at Texas A&M. Basically, we're going to try to prove that there's some sort of link between the decline in health in trees on Texas A&M campus and construction efforts. And we're going to use GPS data to collect some points and how to identify or mark those trees. So for this overview, we're going to talk about, like I previously mentioned, we're going to use GPS to map the trees and poor health and construction areas. We're going to take the data we collect for this areas, this points, the location of those trees and construction areas, and we're going to put them in ArcMap for processing. We're going to interpret and do an interpretation of the data, and pretty much going to discuss the results with the team and justify why we came up to those conclusions.
So for our data collection, we went out and collected GPS coordinates of trees that weren't looking too good, that had lots of health problems or dead limbs, too much moss, and various other things. The goal of going out and collecting the GPS data was to plot it into a map on ArcMap. That way we could visualize the actual distribution of trees with poor health around campus. After the points were collected, we would then be able to see if there was any kind of correlation between construction areas and the trees with poor health themselves.
For the tree plotting criteria, we decided to go with 30% or more of ball moss coverage. Basically, we decided on that because ball moss is a sign of weakened immune system, which also contributes to the amount of weight that the limb can attain during water or any precipitation. It can cause the tree to have any structural failure. We also went with mistletoe the presence in the tree as a sign of poor tree health because mistletoe can be considered a pathogen in the tree, which is also absorbs nutrients from the plant itself. And also another sign of declining tree health is dieback on the trees, basically where pretty much the tree starts to compartmentalize the trees, the branches, and pretty much kills the end of the branches and pretty much reduces its foliage and structural defects such as any kind of decay in the trunk or the main parts of the tree that can lead to failure.
So for our construction areas that we were mapping, things that we looked for to, I guess, classify an area as a construction area was anything that was really visible that stood out to us. So like busted up sidewalks, construction fencing, heavy equipment, anything where there was a lot of disturbance going on, lots of stuff coming on and off campus. Anything that may have an effect on the trees in the area.
So for key assumptions, we're going to assume that construction activities on campus are usually going to have some sort of heavy machinery. Basically, this is a problem, especially around trees, because the way of the machinery use can lead to soil compaction. Basically, can kill the root system and prevent it from use. The soil needs some sort of a space. The pore space becomes so small that the roots themselves cannot absorb any nutrients or water. Also, whenever the sidewalks are being constructed, we can assume that they're going to need some sort of a dig in the trenches. Well, this can be a problem when it comes to the root system as well, because the roots themselves will be damaged or sometimes even removed. As you can see in the image provided in this slide, the roots can be damaged and pretty much the nutrient uptake is now non-existent for that root system or that part of the root system now. Yes.
What am I gonna talk about?
Just give a brief description of that on there. collect that using the GPS remote, imported a map, and
What was the buffers? Or is that already going to be talked about right?
No, we haven't talked to it. But
no, it's just great intersect between the buffers. Ran a 5-meter buffer on trees and 15-meter buffers.
Okay. Okay, cool. Alright. Here we see the layers of the map created, along with zooming in on West Campus. You can see that there aren't many trees, but the trees that there are vast majority within the construction zones and have been proved to be unhealthy. Next slide, we have main campus, more towards West Campus. Most of the trees here have been are unhealthy, but there aren't too many construction zones to determine whether or not there's a correlation. But on the right side, you more of the academic building and where current construction is going on, and you can see that there's more of a correlation, especially with like the fine arts building and the building in between towards Evans. And continuing on, the engineering is where most of the recent construction has been going on, and currently there's no trees around that area because the construction is new, and with new construction they bring in new trees, so the trees have not yet been impacted by the construction zones and heavy machinery. So our limitations, we weren't able to create shapes of the construction zones from the points, and the buffers themselves do not cover the entire construction zone. So there is a limitation on the ability of intersection between the trees and the construction zones. We also weren't able to map all of campus, and there's a lack of knowledge of recent construction zones because most of us have only been here for 3 to 5 years, so anything beyond our time of being here, we have no recollection of when it was constructed or remodeled. And there's, again, with new trees being planted, there's with the new buildings, so they have yet to be impacted by the construction.
So, in conclusion, based on the construction data and limited knowledge of the extent of construction, it appears that construction developments do negatively affect the trees at Texas A&M. There are trees with poor health throughout the entire campus, but where there is construction or evidence of construction activities, there's definitely noticeable signs of poor tree health.
Just say that, just say fuck.
Well, he did say something like that in one of the slides, one of the videos himself. It's like he stuttered and like started repeating.
You watched those?
Oh yeah. He's like,
I should have. Sierra was like, "Oh, fucking son, fucking."
Yeah, because I mean, you can clearly hear somebody opening the door too, and he's doing like.
Pretty sure I have Dr. Klein on this child porn. Funny story about Dr. Klein and porn. One of my buddies that I took 390 with. What's the correlation? He was like doing an interview or something, and the guy was interviewing asked if he had ever had Dr. Klein, and he was like, "Well, yeah, I've got him right now. Or I got him for 2 classes." And he was like, "No shit." He said, "I went in his office one time, and he told me to go look something up on his computer." And when I went to his computer, he had like 3 Pornhub tabs.
Yeah.
Open. You can't do that on camera.
So for this last slide, it's just the sources of our photos that we got for demonstration of ball moss and construction areas, and some examples of how trenching can damage the root system in trees.